Okay, the next lesson, lesson set 26, is going to be working with the logarithmic form of the exponential and then logarithmic equations. We have looked at some exponentials, but now we want to look at logs. Logs, sometimes people think that they are confusing, but it's really just asking for the exponent when you have a positive base and you know what the answer is going to be. So, for an example, we know right now that if we take any positive number, we can write it as a positive base raised to a positive number. So we know that a number can be written in the format of a base raised to an exponent. L is what they're calling it in your book. So another way you can write that is log n of base b is equal to L. Now what I like to say is that we have this argument or this answer in which we have a base raised to an exponent. We can change that over into logarithmic form by saying the log of base b, because my base over here is b, of your argument, also known as the answer, is equal to whatever your exponent is. So how can we go through and change forms? So just as example number 1, to change formats, if I tell you I have 4 is equal to 3 to the y power, we can change that into logarithmic form. We're going to say log, and then the little subscript value right here is your base. So your base is 3 of the answer, which is 4, is equal to the exponent, which is y. So this is in logarithmic form. You're taking an exponential, which is right here, and you're changing it into logarithmic format. Now we can go the other way, such as in example 2 here. What if I ask you to take the log of base x of the value 4, so log 4 base x is equal to m. If I ask you to change that into exponential format, your base is x, the exponent, if you look over here, your exponent is m, and that is equal to the answer of the argument, which is 4. So you're converting from either exponential into logarithmic or logarithmic into exponential format. Now what we want to be able to do with these is, in essence, we just want to be able to find what the exponent is that's going to make an equation true. So if I ask you to just simply solve, I'm going to give you a problem. So solve log 8 base b of 3. What this is asking you is, in order to solve it, they're giving you the exponent and they give you the answer and they want to know what is the base. So in order to solve this, we could change this into exponential format. So you take your base raised to the exponent is equal to the answer or the argument, just going up here and referring to converting between these two formats. We know that 8 is the same thing as 2 cubed. So that means that b has to have a value of 2. So what number to the third power is equal to 8? That's what that question is asking you. That's all a log is asking you to do. So let's look at another example. Let me slide this up a little bit. And another example, I am going to ask you to solve log 9 base b. Log base b of 9 is equal to negative 1/2. So again, let's put that into exponential format. In exponential format, your base is b, found right here. Your exponent is found right here, so b to the negative 1/2 power is equal to the answer, which is 9. Now if we want to solve that, what we need to do is think about, what do you do to an exponent to get rid of it? If that were just the square root, say it wasn't the negative 1/2 exponent, if it were just the square root, I would square both sides. What you want to do is you want this exponent of your variable to be 1. So I know that we have, clear back in Algebra 1, we talked about multiplicative inverses. And when you take a number times its multiplicative inverse, you get 1. So I know that if I take, what I was saying before, if this happened to be the square root, which is what the 1/2 power means, I know that if I take that and square it, it would make that exponent 1, or that gets rid of each other. A square and square root get rid of each other. In this case, I want this exponent to be 1, so I would have to multiply it, or not multiply it, but raise it to the -2 power, so that when you multiply those exponents, you get 1. So when you have this exponent, to get rid of it, you multiply by its reciprocal. If you do that to one side, you have to do that to the other side as well. So if I take -1/2 and I raise that to the -2nd power, I get 1. And that leaves me with the answer of 9 to the -2 power. 9 to the -2 power. 9 squared is 1. The negative exponent says put it in the denominator. And your answer is 1/81. 1/81. So revisit that. Change it into logarithmic format, which is in red. You raise it to the reciprocal power, which is -2, but you have to do that to the other side, and then simplify that. Okay, here's example 5, another example. Once again, change your logarithmic format into exponential format. So your base is 3, you are raising that to the m power, and that's equal to 1/27. Now some of you are going to recognize this and realize that it's 3 to the -3rd power. What you can do is you can make sure you write both sides of the equation in the same base. So 1/127 means the same thing as 1/27 is 3 to the 3rd power. And if I move that up, you are going to get 3 to the -3rd power. So 1/27 is the same thing as 3 to the -3rd power. If the bases are the same, and they are both, and these are equal equations or statements, they're equal statements to each other. So if the bases are the same, those exponents have to be the same, which means that m has to equal -3. And there's your answer. Okay, here's another example, example 6. Change the logarithmic format into exponential format. Your base of 1/3, your exponent, or raised to the power of -2, is equal to the argument or the answer, which is p. So now you just need to calculate 1/3 to the -2 power. 1/3 squared is 1/9. The negative exponent says take the reciprocal. So p is equal to 9. Okay, so let's look at example 7. We have log base 4 of 8 is equal to x. So change that into exponential format. Your base is 4 raised to the x exponent is equal to the answer argument of 8. Now this one's not as easy to see because you think of 4. Well, 4 to the first is 4. 4 to the second is 16. So it's got to be somewhere between 1 and 2, which says it's going to be a fractional exponent. But what we can do is just like one of the other examples with the 3 and the 9 where we wanted to put them in the same base. Try to put these in the same base. We know that if we go back and look at it, 4 is the same thing as 2 squared. And what we are doing to that is we are raising that to the x power. So you have 4 to the x power. I just changed the 4 to be seen as 2 squared. And on the other side, 8 is the same thing as 2 cubed. Now remember, when you take a power and you raise it to a power, you multiply those exponents together. So if you multiply those exponents together, the left-hand side of the equation becomes 2 to the 2x power, and that's equal to 2 to the 3rd power. these two values on both sides of the equal sign are equal to each other. That's what the equal sign means. So if the bases are the same, then the exponents have to be the same. And if I solve 2x is equal to 3, you divide both sides by 2, and we find out that x is equal to 3/2. And if you look at it, you take 4 to the 3/2 power. I do the root first. The square root of 4 is 2. 2 cubed is 8. And that is what we are looking for. Let's look at this next example. Example 8. We have log 27 base b, or log base b of 27 is equal to 3. So changing it into exponential format, your base is b, the exponent is 3, and the answer is 27. You could, if you wanted to, some of you already know that 3 to the third is 27. If you wanted to, we could say to get rid of that, we're going to raise it to the reciprocal power. So we're going to raise both sides to the reciprocal power, and the cube root of 27 is 3. So your answer is 3. Okay, example 9, change it into exponential format. So 2 to the m is equal to 1/8. If I write it as the same base, 8 is the same thing as 2 cubed, but it's in the denominator, so that's a negative exponent. So I know if I take 2 and I raise it to the negative third power, I get 1/8. If the bases are the same, the exponents are equal, so m equals -3. Oh, what a coincidence. Example 9 does happen to be problem number 9 on the homework assignment. And I think that example 8 is problem number 8 on your homework assignment. So let's look at example 10, which might possibly be problem number 10 on your homework assignment. So you have log of base 1/2. The argument is c, and that's equal to -4. So if we were to solve that, change that into exponential format. So if you change that to exponential format, the base is 1/2. Your exponent is -4, and that is equal to c. So 1/2 to the 4th power. Just think of raising both the numerator and denominator to that power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we get 1/16 is equal to c. And that's all you have to do is just go ahead and calculate what 1/2 to the -4 power is. Some of you are just going to type that in on your calculator. So there's the next lesson, lesson set 26. Thank you for being patient for me. Last week it was taking me 3 to 4 hours to upload a 15-minute video and still was not working. My internet had gone out. So hopefully doing this on a Sunday, it's only taking me an hour to create and upload a 15-minute video for you. So thank you for being patient last week. Sorry about all of the troubles, and I hope this video helps.